Hi, welcome back. Today we're going to be starting we're in a super duper AP review session, and we're going to be taking a look at some AP practice questions from a packet I handed out to you guys. So we're going to start off with this question right here. It is an area volume question from the 2022 AB exam. It's a really good example of how to find areas and volume. So let's take a look. We have the region R. It's enclosed by this cosine curve and this parabola. And it also has been bounded by the y-axis, or x equals 0, and the vertical line x equals 2. For question A, we want to find the area. Now, to get the area, we're going to draw our rectangle of mathematics somewhere in this. And there's my rectangle. There it is. And I can fill it in. Now, if I were to blow that rectangle up, make it really bigger, I know it has a thickness dx. And to get the height, we're just going to take the top of that rectangle, subtract it from the bottom. Now, the height of the rectangle is h of x. So I'm just going to go ahead and write that out. H of x, that is our parabola. The bottom is just g of x. So if I want to find the area, of course, it's just length times width. There's or base times, if you want to do base times height. So it's just the area of a rectangle for us. So let's take a look at part A. Let's go and set this up. I want to find the area. And to get the area, we know we're going to take the integral. They already gave us the bound 0 to 2. Now, because this is non-calculator, I am going to have to write out the function here. And it's not going to be the nicest one. We're going to get this negative 2 plus, it's h of x. I was writing down g of x. So h of x, which was our parabola, which was this 6 minus 2 times x minus 1 squared, minus g of x, which is our cosine curve right there. And that's going to give us negative 2 plus 3 cosine pi over 2x dx right there. I'm going to clean this up a little bit, not too much, just make sure, just so I don't have to write too many parentheses when I solve it. This becomes 6 minus 2. I could expand that one if you want to, but I'm not. X minus 1 squared plus 2 minus 3 cosine pi over 2x dx. Now I have to evaluate this integral. Now notice we have two u substitutions, and I'm going to do them both at the same time here. So the first u is going to be for this x minus 1 squared. So I'm just let my u be my inside, x minus 1. The du would just be dx. And I could plug that back in. That's just going to become 6 minus 2 u squared plus 2 minus 3. But now I have this cosine one. And I'm going to do that one. Our u here is going to be pi over 2x. Our du is pi over 2 dx, which gives us dx is 2 over pi du. And I'm going to write that. So what this is telling me is I'm just going to multiply by 2 over pi, and that's going to become this cosine of u times 2 over pi du. Now, notice it's not really a true u substitution because notice these u's are not the same. We can't really treat them the same, but we can integrate it now. So when I integrate, this is going to give us 6x minus, this becomes 2/3 u cubed. Remember here, u was this x minus 1 cubed plus 2x minus 3, the antiderivative of cosine is just sine, so sine of u, remember sine here was pi over 2x times 2 over pi. And there's our antiderivative. Oh, nasty little bugger. We would evaluate this from 0 to 2. And now we just do the FTC. F of 2 minus f of 0. It's not going to be pretty, but we're not going to simplify it. Plugging in 2, we're going to get 12 minus 2/3. Plug in 2 here, we get times 1. Plus 4 minus, now this is interesting. We're going to get if we were to plug the 2 into sine of 2 pi over 2x, the 2's cancel, we get sine of pi. So this whole quantity is just 0. That's the 3 sine of pi right there, just 0. Plugging in 0 now, plugging in here, we get 0 minus 2/3 times negative 1 cubed plus 0. And again, if we plug 0 into pi over 2x, that just becomes 0 because sine of 0 is still 0. So again, just this whole big minus 0. And there's your answer. Do not simplify that. Leave it alone. All right. So let's take a look at part B. Now, part B says region R is the base of a solid. For each solid, the cross sections perpendicular to the x-axis has the following area. So for cross sections, remember to get the volume, it's just the from A to B is the area of the base times the height, which for us is either dx or dy, depending on what we're doing. Now, luckily, they already gave us the area of the base here, so that's nice. So let's take a look here at number B, at B. So to get this, we have a cross section. So to get this one here, to get our volume, it's just going to be the area of the base times the height. Well, they tell us that the area of the base is 1 over x plus 3. Now, we are perpendicular to the x-axis, so therefore we have to be in terms of x. So our height then is just going to be dx. And we would integrate that again from 0 to 2. And you probably get a point for setting that up. Solving it, this is just our natural log, x plus 3, evaluated from 0 to 2, and that's just going to become the natural log of 5 minus the natural log of 3. Yippee. Very easy, 2 or 3 points right there. Part C, let's take a look here. Now for part C, let me scroll up. Write my favorite phrase, do not evaluate. Do not evaluate an integral expression that can give the volume when the region is revolved about the line y equals 6. This is our washer method. So I'm going to go ahead and redraw it just so we can kind of see it a little bit better. Let me make sure I got it down here. We'll go if I can copy this. Ready? Copy. Let's see, will this work? Paste. Doesn't work that way. Oh, look, at least I don't need that though. All right, so let's take a look up here. So it goes squiggly, low squiggly. So let me see if I can copy that down here. Not drawn the scale. There we go. There we go. And there's our line x equals as 2 right there. So we're going to revolve this about the line y equals 6. And there it is right there. And we are rotating it. So this is our washer method because if I draw it out, I'm going to go straight down and I have this big shaded outside part. So setting up this one, we have our washer. What we need to find is our outside radius. And I can do that really quickly by taking the top, which is at 6, there's my top, minus the very bottom, which was our sine function. And that was this function right here, g of x right there. So that was this minus negative 2 plus 3 cosine pi over 2x right there. Now I need my inside radius. Now remember, the inside radius is really the hole that we're looking at. That's right here. There's our inside radius, right? And there's our outside radius right here. So to get our inside radius, again, it's top minus the bottom. The inside radius right here, our top is still the 6, and our bottom is the parabola this time. So we would get 6 minus our parabola. So what's the equation of our parabola? It was 6 minus 2, x minus 1 squared. So 6 minus 2, x minus 1 squared. I can clean that up if I wanted to. This comes out nicely. 2x minus 1 squared. All right, so now we get the volume. So to get the volume, remember this is volume of the outside minus the volume of the inside. So it's going to be pi radius of our outside squared minus radius of our inside squared dx or dh or times h right there. That's a formula if you want to memorize it. I'm not a big formula fan, so I just set it up. The volume is just pi, the integral, the radius of our outside. I'm just going to write it all the way up. I ain't making it look nice and pretty. Cosine pi over 2x squared minus the inside. 2x minus 1 squared dx. Now, pi radii squared, outside minus the inside squared. And this is going to go from 0 to 2 still. This is a 3-point question, so you want to make sure you can practice that one, okay? All right, hope you guys enjoyed the video. I'll see y'all later. Bye-bye.